I am now going to talk to you about data types, and we're going to start with the number data type. So Python can deal with numbers as integers and reals or floating points. So we'll look at those first. So an integer is obviously any number without the fractional part. So in this example 43, and we can type that directly at the interactive development environment or put it into a variable. And similarly, we can do the same with floating point numbers. So anything with numbers after the decimal point is considered a floating point number. Now, what we do when we're working with floating point numbers or real numbers is that we continue to work with the number of digits behind the decimal place, but then when we want to format them, let's say with 2 decimals, we print them using just the 2 decimals at that stage. Python also allows you to work with base 8 and base 16 numbers. So a base 8 number, if it's prefixed with a 0 and then the letter O, anything after it would be an octal. So here we have 0 and O. That's telling me it's an octal number. And then I have a 1 and a 0. So 0 is in the units position, so there's no units. 1 is in the 8 position, so my number is 8. Hexadecimal or base 16 are prefixed with an a 0 and the letter X. So it doesn't matter if it's uppercase or lowercase. So you can see here, this is my hex number. So it's 0x, so it tells me it's hex. And then I have an a 0, and an F. So F is in the units. 0 is in the 16. And A is in the 16 multiplied by 16. And that gives me a value of 2575. Okay, let's just have a look at some of that code. Okay, so I'm going to run this first and we can have a look at what the results are. Okay, here we go. Okay, so the first thing I did was I printed 4 plus 3. So 4 plus 3, so even though it's coming inside the print function, the plus operator does operations on those 2 integers. So it knows it's 2 integers and it gives me an answer of 7. 4 minus 3, answer of 1. 4 multiplied by 3, so the star is the multiplication, it gives me an answer of 12. And 4 divided by 3, the answer is 1.333 recurring. Okay, and there it is there. So that's the divide, multiply, minus, and add. Okay, and similarly, I can just do these at the line as well. I can do 5 plus 7 and return, and I get the answer 12 here. Okay, the percent sign is not actually a percent of its modulus mats. So that's the remainder. So if I look at 4 modulus 3, the answer is 1. So 4. So when I divide 4 by 3, what's the remainder? So 4 divided by 3 goes in once, with 1 left over, it's 1. 100 divided by 9, the answer is 1. So 9 into 100 goes 11 times 99, and then I'm still left with 1. So let's take, for example, 17 modulus 7. What's the answer going to be? So 7 goes into 17 twice, that's 14, and leaves me a remainder of 3. Okay, so that's really handy if you want to write little games, for example, to check if something's a leap year, it would be modulus 4, if a number is odd or even, so modulus 2. If modulus 2 is equivalent to 0, you know it's an even number. Modulus 2 equivalent to 1, we know it's an odd number. To raise something to the power, we use the multiply, so star, star. Okay, and so here we have 4 raised to the power of 3, give me an answer of 64. Okay, so 2 raised to the power of 2 will give me 4. Okay, operator precedence comes into play when you're working with maths, and they don't always execute from left to right. So I might expect that the answer to this will be 7 plus 3 is 10, multiply the whole lot by 2, and I get the answer of 20. However, when I run it, you see I get an answer of 13. So this is because in programming languages, different operators such as your multiply, your divide, your plus, and your minus have precedence over each other's. So multiplication would happen first. So here it looks at this string that I'm sending it in. It does the multiply first. So it multiplies 3 by 2 and gives me 6. And then it adds that to 7. So I get an answer of 3. So what I'd need to do is use my brackets around that. So let's try it again. So 7 plus 3 multiplied by 2 gives me an answer of 13. One second, sorry. Okay, but if I do 7 plus, 7 plus 3, and multiply the whole answer by 2, I get 20. Okay, so the brackets, just like in normal maths, the brackets allow this bit to be executed first. So just be careful of that when you're doing your maths. Okay, working with floating point numbers, it's exactly the same as working with integers. So here I've added in, 2.765 but plus 2.3, and I get an answer of, where is it? Somewhere here. I added a whole lot of junk, so at the end. Here I'm doing a minus with reals. Again, I get a similar sort of minus there. Multiply, I get a multiplication. Okay, so floating points, you do normal sort of maths on those. Okay, but when we want them to print out, we often want to print out something better than looks like this. We want to print it out in perhaps rounded to 2 decimals. Okay, so the round function takes a number and rounds it to the nearest decimal place. So in this example, I've asked it to round it to 2 decimals. So it's going to cut it off here. Now, and it rounds it up or rounds it down based on where it is nearest to 5. So it's going to take 0.86, and the 0.00574 is nearer to the upper rather than the lower bound. So that'll give me 98.87, which it has over here. Okay, so round actually changes the number. So, okay, so 1.33 is different to 1.3333333333. Okay, so round will actually cut off all those 3's and just leave me with the 1.33. So it's a very different number to that one. So what we tend to do is not use the round function unless you need to, but then change the output with a format string. So you can see what I've done here. In this one, I've still got my 4 divided by 3, which is my 1.333 recurring. But I've said to print it, I wanted to print it using this format. So the format is an apostrophe, curly brackets, colon, and then what's my format? So it's dot, so decimal point 2, and there's F, end my brackets, end my colon, dot, and the word format. So it takes 4 divided by 3 and then formats it according to this string mask that I'm giving it. Okay, and here you can see there's my 1.33 there. Okay, similarly I've done the same thing here. This time I've used double quotes. You see it works fine. And I've formatted this number 3.1415926 to 3.14. That's fine. If I want to format the number but show the sign, so I want to show either a plus or a minus in front of the number, I need to use this little symbol here in my format string. So I've got a plus here, so it's apostrophe or quotes, curly brackets, colon, and then plus, so the sign, followed by a decimal and 2 decimal places in my format. So this will give me my minus 12.5643, and it will round it, sorry, it won't round it, it will format it to just 2 decimal places, which is minus 12.56. Okay. Another format option is to use a comma in the thousands. So it's the quote, curly brackets, colon, and then what's my format? So it's a comma, and then I end that string. So this is the number I'm giving it, and this is what I get out. Okay, so I get commas here in my thousands. Okay, how to express at a percentage. So we saw earlier on that the percent sign doesn't actually do a percentage, it does modulus maths for you. So to do a percent, you have to simply just divide by the numbers. But here, if I want to display the format with a percent at the end, so here I want to display 4 divided by 3 as a percent. So it's my straightforward string, and I'm using this % symbol here. And when I print it, you see it's giving me whatever it is here with the % at the end. Okay, and here combining formats, you can see in this one I'm asking you to do the commas in the thousand and 2 decimal places. So I simply list in this section here all the different formats that I want to appear, and that's how I combine the different formats. So this will give me this. So I've got commas in my thousands, plus I've got 2 decimals. Okay, I mentioned earlier on that there were different number bases, and if we prefix a number with a 0 and an O, it becomes an octal number. Okay, so this is my octal here. So I have 1 in the units position, so that gives me a 1. I have 0 in the 8 position, and I have 1 in the 8 multiplied by 8 position, so 8, 8, 64. So my answer is 65. So 64 plus 1 is 65. Okay, here I've got 1 in the units position, so I've got a 1. I've got 1 in the 16 position, and I've got an A, which is the 10, in the 16 multiplied by 16 position. And I know it's hex because I prefixed it with O and X, and that gives me 2574. Okay, I can convert between the different number bases. So to convert 70 to binary, I do print, and the function is binary or bin, and then in brackets the number I want to convert. So that converted, so I've got my 0B here that tells me it's a binary, and that's my number 70 in binary. I'm converting 70 to octal base. Okay, so my 0O tells me it's octal, and that's the number there. And the hex function converts it to hex. So that tells me this is a hex, and the number is 46. Okay. And similarly, I can do maths like I've done here at runtime. Okay. Python will also work with complex numbers. So if that's your thing, and you're into quadratic equations and so on, Python will work with those, and it will compute them for you. Okay, which is a really handy function if that's what you're into. Okay, I want to just show you another thing. Printing in integers. Okay, I'm going to run this for you here. Okay, let's just see what results we get. Okay, so here I've got a number 6 which I've assigned into a variable, called number 1. So number 1 is an integer variable. Now the system knows it's an integer variable because when I assigned a value to it, the value I assigned was an int. Okay, so it's an integer variable called number 1. Now that's different to other programming languages. Say, for example, with your programming in C++, you'd have to define it as int number 1, and then assign a 6 to it, or whatever the number was. Okay, so this would be in C++. In Python, we don't need to define the type because it's sort of loosely typed. So number 1 is a 6. I've assigned a value 3 to a variable called number 2. And then I print the screen. So I'm printing number 1 plus number 2. So what's held in number 1, 2 what's held in number 2, and print the result, and it's giving me a 9. Number 1 minus number 2. So whatever is held in number 1, which happens to be a 6, minus whatever is held in number 2, which happens to be a 3, and it gives me 3. And similarly, number 1 multiplied by number 2 gives me 18. And number 1 divided by number 2 gives me 2. Now it's interesting here that it's appended a decimal position to that. So it can change. It's dynamically typed, so it can change the type. So we might have started off with an integer, but when we divide the two of them, it doesn't necessarily always give us an integer. It's after giving us a real. But we'll look at types later, and we can change that type back if we want. Now the beauty of putting numbers into variables rather than hard coding them in, hard coding them in like this, 7 plus 8 or whatever,